Evolution is a slow but sure process that, in most instances, takes millions of years before any serious notable changes can be noticed. One question that has puzzled many people is, why were animals so big in the past? For a long time, environmental factors such as higher oxygen content in the air and greater land masses were thought to contribute to their large size. To understand how environmental conditions may have contributed to the evolution of larger and more complex animals in prehistoric times, it is important to consider the types of habitat that would have been common during this era. In particular, these organisms likely lived in warm, moist climates where food was abundant, and there was a limited competition for resources. Given these conditions, natural selection may have favored traits such as increased body size over features such as heightened agility or speed, as bigger animals were better equipped to survive and thrive in this environment. Additionally, natural selection may also have favored a long developmental period to allow animals to reach larger sizes before reaching maturity. Ultimately, the combination of ideal ecological conditions and adaptation towards body size allowed many ancient species to flourish in prehistoric times. Large animals tend to produce a lot of CO2, which led to an increase in vegetation, which meant food availability for most dinosaurs. It also meant the availability of a lot of oxygen for these prehistoric animals to sustain themselves. Abundant oxygen can be a major factor in the accelerated growth of some animals in prehistoric times. A good example is the cockroaches from the Paleozoic era, which were able to grow as big as modern-day domesticated cats. These cockroaches benefited from the excess oxygen that was available in the atmosphere. Cope's rule, which says that as animals evolve over time, they get larger, was another generally accepted explanation. People thought that prehistoric animals evolved during the thousands of years between mass extinctions, growing larger as time passed. When the next mass extinction occurred, the huge animals were wiped out, and new, smaller animals took their place, growing larger until the next extinction. Cope's rule also explained why we don't have enormous land animals today, at least by prehistoric standards. It has been 66 million years since the last mass extinction, the Cretaceous mass extinction, which wiped out the dinosaurs. That's not long enough in evolutionary terms under Cope's rule for creatures to become enormous. Overall, prehistoric animals were notably bigger than modern animals up until very recently. The perception that prehistoric animals were usually big results from confirmation bias on a few specific exemptions. In the Cambrian period, the largest animals were anomalocarids, which got no larger than 6.5 feet long. That's much smaller than modern animals. In the Ordovician, the largest animals were the Camaraocerid cephalopods, which could grow to around 30 feet, but most of that was the shell. This is in the same range as today's giant and colossal squid, and much smaller than the largest ocean animal, the whale. In the Devonian, the largest animals were the Dunkleosteus, an armored fish that ranged from 20 to 30 feet in length. This is just a bit bigger than the great white shark, roughly the same range as the orca, and much smaller than the largest whales. In the Carboniferous, we have our large anthropods, which benefited from the high oxygen levels. Certainly, these critters were big compared to other arthropods. However, the largest of them were still only 10 feet, and in mass would be in the same ranges as modern lions and bears. Big, yes, but certainly not as big as the biggest modern land animals. In the Permian, the largest land animals were the Gorgonopsids, which topped out in size at about that of a rhino. Big for sure, but modern elephants are still bigger. In the Triassic, the largest land animals were the prosauropods. The largest of these are about the same size and mass as today's biggest elephants. It is only in the Jurassic and the Cretaceous that we really get prehistoric land animals much larger than modern ones. And these, notably, were all members of one group, the sauropods. All the other dinosaur groups had their largest members roughly the same size as the largest modern elephants, at best a little bigger. Tyrannosaurus rex, Spinosaurus, and Triceratops, the largest hadrosaurs, were roughly the same size and mass as the largest modern elephants. In the air, it was the same thing. One group of pterosaurs, and one group only. The Azhdarchids, such as the Quetzalcoatlus, grew unusually big. Still, the rest of the pterosaurs were in the same size range as modern birds. Pteranodon was roughly the same size as Argentavis, the largest ever bird, which in the grand scheme of things went extinct fairly recently. In the oceans, the animals were not actually notably bigger than modern ones. The big marine reptiles ranged in size from 30 to 60 feet. The largest made it to about 80 feet, though those estimates are disputed. In comparison, today's blue whale can reach lengths of 100 feet, the fin whale over 80 feet, and the sperm whale 50 to 60 feet, with the largest reported examples from the age of whaling reached 80 feet, and the humpback whale 40 to 50 feet. We can see that the size ranges are equivalent, and if anything, today's whales have a slight edge in size. Going past the KT mass extinction, when animals got large again in the Miocene, the largest land animals were the Enterocotheres, which are relatives of rhinos. These guys got to masses in the middle of the sauropod range and were a fair bit bigger than today's largest elephants, but not monstrably so. Then, as we approach modern times, the largest land animals were ancient elephants, the largest of which approached the Enterocotheres in size. In the oceans, we started seeing the whales grow to sizes approaching modern times, but no ancient whale got as big as today's blue whale. Megalodon, the giant shark, reached 50 to 60 feet, in the same range as the sperm whale and the big Mesozoic aquatic reptiles. So the pattern we see is that, since the appearance of animals in the Cambrian, the largest animals gradually grew until most lineages topped up at a certain maximum range by the middle of the Mesozoic. From then on, most of the largest animals of every era and most lineages grew large, stayed in that range, with a few specific families that managed to break the rules and get larger for evolutionary reasons particular to that lineage, like the sauropods and the Azhdarchids and today's blue whale. Since these rule-breaking lineages are rare just by chance alone, it is more likely that they would appear in prehistoric times rather than modern times, simply because there is much more prehistoric time than modern time. We remember these unique lineages because of their unusualness, creating the perception that animals were bigger in prehistoric times. But it is just that, a perception based on confirmation bias. When we get to very modern times, we see a recent trend towards diminishment of maximum size. The elephants living today are, on average, smaller than the largest known elephants even in recorded history. Also, there are few sperm whales or even blue whales observed today, reaching the maximum sizes we recorded only 200 years ago. The reason for this is simply human activity. Sadly, we have killed off the largest animals quite recently through hunting and whaling. The largest animals also need a lot of space to live and a lot of time to grow. There are so many people on Earth now, using up so much of the Earth's resources that there isn't enough space for the largest of the large to make a living anymore. The various dangers of the human world mean that fewer and fewer individuals get to live long enough to grow to those extreme sizes. That's all for today. If you enjoyed this video, don't forget to like, subscribe, and share it with your friends. You can also leave a comment with what you would like to see in the following videos. Thanks for watching. See you next time.